Hello friends, welcome to a fresh new episode of our channel RG Innovations. If you have not subscribed already, please subscribe to our channel, click on the bell button and select all to get all future notifications of our video uploads. In my previous video, I have discussed what is EEPROM and how to use the internal EEPROM of Arduino. In today's video, I will discuss how to use external EEPROM with Arduino. We will discuss about AT24C256 module. This is a 256 kilobit module, that means it's a 32 kilobyte memory. Now as the video continues, we will learn more about this. First, let us learn few basic features of AT24C256 module. The AT24C256 is a popular EEPROM or electrically erasable programmable read-only memory chip that uses the I2C, that is Inter-Integrated Circuit Communication Protocol. It offers various features that make it suitable for a range of applications where non-volatile data storage is required. At first, we will look into a summary of its key features. The first and foremost thing that we know about this module is it's a 256 kilobit module. It is not a 256 kilobyte module. It's a 256 kilobit module, that means 32 kilobytes module. The AT24C256 has a total capacity of 256 kilobits, equivalent to 32 kilobytes of storage. This capacity allows it to store a significant amount of data, including configurations, calibration data, logs, or small data structures. The next thing that we should know, it supports I2C communication. The chip uses the I2C communication protocol, allowing multiple devices to be connected on the same bus with only two wires, SDA for data and SCL for clock. The default I2C address is 0x50, but it can be changed by manipulating the A0, A1 and A2 address pins, providing up to 8 unique addresses on the same bus. We will see more detail about this later. This module has byte-oriented structure. The memory is organized at 32,768 bytes, with each byte having its own address. It uses a 16-bit address, allowing it to access all the 32,768 bytes. When writing or reading, you specify the 16-bit address to indicate where to start. Sequential read capability. The EEPROM allows continuous reads from a given starting address, reading through to the end of the memory if desired. Standard and fast I2C modes. The AT24C256 supports standard I2C speeds, that is 100 kHz, and fast I2C speeds, that is 400 kHz, allowing for flexible integration into various systems. Write timing. Each write operation typically takes around 5 milliseconds to complete, which is important to consider when planning the write operations. We must allow 5 milliseconds to write the data into this module. Write endurance. The AT24C256 has a write endurance of around 1 million write cycles per byte, providing durability for typical applications. In the internal EEPROM of Arduino, we learned that it allows only 100,000 times of writing, but in this AT24C256, it allows 1 million write cycles. Data retention. The EEPROM retains data for up to 100 years at a storage temperature of 25 degrees centigrade, whereas in the internal EEPROM of Arduino, it was only 10 years of data retention. Now, write protection. The write protect pin allows you to disable write operations, ensuring that the critical data is not accidentally overwritten. Low power consumption. The EEPROM consumes little power during operation, making it suitable for battery-powered applications. Wide voltage range. The chip operates over a wide voltage range, typically 1.8 volt to 5.5 volt, allowing compatibility with various Arduino boards and microcontrollers. So these features make the AT24C256 a versatile EEPROM chip, widely used in microcontroller-based projects for persistent data storage and retrieval. It's suitable for applications in embedded systems, data logging, calibration storage, and more. Now we will learn more about AT24C256 module. So this is how the module looks like. This IC is the memory IC 24C256, you can see. It's a 8-pin IC. We will discuss all the pin configurations in our next slide. But for now, we are just having a look of the module. Here we can see 4 jumpers are here with A0, A1 and A2 pin and a WP pin. And at this side, there are 4 pins, that is VCC, SCL, SDA and ground. So what are these pins for? The A0 pin is address input, The A1 pin is address input, the A2 pin is address input. Using these three pins we change the I2C address of the module. The ground pin here, the SDA pin, that is serial data pin, the SCL pin, that is serial clock input, WP is the write protect pin, and VCC is the device power supply. We can see some jumpers here. These four jumpers at WP pin, A0 pin, A1 pin and A2 pin. If we move this jumper in the WP pin from this position to this position, this module will be write protected. And to adjust the I2C addresses of these modules, if we use multiple module, we use these jumpers from this location to this location. Changing this jumper setting, we can change the I2C address of this module. We will come to that discussion in a few moments. Now let's have a look at the IC pinout. If we consider this to be the IC AT24C256, here are 8 pins, pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8. Pin 1 is the A0 pin, pin 2 is the A1, pin 3 is A2, pin 4 is ground, pin 5 is SDA, that is serial data, pin 6 is serial clock, pin 7 is write protect, and pin 8 is the power supply pin. Now how to connect this IC with Arduino? If we do not use the module, if we directly connect the IC with the Arduino, this will be the schematic. Pin number 1, 2, 3, 4 will be grounded, VCC connected to the positive power supply, WP pin, write protect pin connected to ground, pin 6 to SCL, pin 5 to SDA. The SCL pin and SDA pin must be connected to the positive power supply with a pull-up resistance. Now we will see how we can connect the module with the Arduino. In the module, the pull-up resistance are already given, so we need not to connect the pull-up resistance. We can very easily connect the module with the Arduino. The VCC pin to the 5 volt supply, the ground pin to the ground, the SDA pin to analog pin 4, and the SCL pin to analog pin 5. Very simple connection, and if we need to change the addresses, we can change these jumper settings. We will come to that discussion in a moment. Now what we were saying, that I2C address structure, how we could adjust the I2C address. If we are using multiple of this module, we can change the address of each module so that we can individually address the modules. The AT24C256 EEPROM has 3 configurable address pins, A0, A1, A2, as we have already mentioned. These pins allow you to change the I2C address, enabling multiple EEPROMs on the same I2C bus without conflict. By setting these pins to either high connected to VCC or low connected to ground, you can adjust the lower 3 bits of the I2C address. Each combination of A0, A1 and A2 correspond to a different address. Now what is the default address? All pins low. If A0, A1 and A2 all are connected to ground, which is by default there, if we see this module, A0, A1 and A2 are grounded. These pins are ground pins. These are the A0, A1 and A2 pins. These are the 5 volt pins. So these jumpers are connected this side, means these are grounded. So if A0, A1 and A2 all are connected to ground, the I2C address is 0x50. By changing the configuration of A0, A1 and A2, you can adjust the address to any value between 0x50 and 0x57. For example, if A0 is high, the address becomes 0x51. If A1 is high, the address becomes 0x52. If A2 is high, the address becomes 0x54. With all the pins high, A0, A1 and A2, the maximum address is 0x57. In simple words, 50 plus the decimal equivalent of the binary value of A0, A1 and A2 is the I2C address of the module. That means if A0 is high, the value becomes 001, the decimal equivalent of which is 1. So 50 plus 1 equal to 51. Now if A1 is high, then what is the binary value? That is 010. That is equivalent to decimal 2. So that becomes 50 plus 2 equal to 52. In this way we calculate the address. We have a schematic here. If you are connecting multiple EEPROMs to the same I2C bus, ensure each has a unique address. Set the A0, A1 and A2 pins accordingly to avoid conflicts. For example, you can use 8 EEPROMs on the same bus with the different combinations of A0, A1 and A2 pins. See, in this schematic, we are using only 2 wires, SCL and SDA. It's common for all the 3 modules or the 3 ICs. But what we have done is, the first IC has 3 pins grounded, A0, A1 and A2. The next IC has the pin 1 to positive supply, and 2 3 to ground, so its address becomes 0x51, and the next one has pin A1 to connected to positive supply, and pin 1 and pin 3 is grounded, so its address become 0x52. In this way we can use multiple up to 8 I2C modules with an Arduino. Now we will look into the process of accessing the external EEPROM in Arduino. So till now we have seen the module in the pictures only, but now I will show you the module on my hand. So this is the module. You have seen the same thing in the picture. You can see the jumpers here, the pins to be connected with the Arduino. This is here. If I bring it closer, you can see the name of the IC 24C256. Now what I was saying, these jumpers are used to set the address. So if I remove the first jumper and connect it here, this module becomes write protected. So we don't want to do that for now, so we are changing the jumper here, and these three are the address setting jumpers, as I said. So we can also, to change the address, we can set these jumpers here like this. Hope you can see in the picture. You see this jumper has been moved from here to here. So this way we can change the address, I2C address of the module. For now we are keeping this to default, that is 0x50, by having all the jumpers in the default position. Now we will connect the module with the Arduino. We have some jumper wires that we will use to connect. So connecting the VCC with the 5 volt of the Arduino, the ground with the ground of the Arduino, the SDA with analog pin 4 of the Arduino, and the SCL to the analog pin 5 of the Arduino. So our connection is done. Now we will give power to the Arduino. Here we are using Arduino Nano. You can use any version of Arduino, that will work. So giving power to that, you see the Arduino power is on, and the AT24C256 module is also powered on. Now we will go into the Arduino IDE, and I will show you the applications and the output in the serial monitor. So let the module remain connected. We will check one by one all the programs. First writing the module, then reading the module, and then how to clear the EEPROM. So let's move on to the screen. So here is the first program that we will run. This is a program to write 1 byte into the EEPROM and then retrieve the value from the EEPROM. In our last video we have said that byte is the basic unit of the EEPROM. So one memory address can hold 1 byte only. This is the basic program where we will learn how to write 1 byte to a particular address and then to retrieve that byte from the same address. So this is a very simple program. First we have included wire.h. This library is used to access the I2C protocol, and then in the setup section we have used wire.begin. That means the I2C communication is initiated, and then serial.begin means serial communication is initiated. Then in the loop section we have written while not serial, that is until we open the serial monitor the program execution will not start. Then we have defined 2 variables of integer type. One is device address, that is 0x50. It is the default address of the EEPROM module when we have kept the A0, A1 and A2 jumpers in the default position. And in the variable memory address we have set the value 1, so we will write the byte value into the memory address 1. As we have described that in the AT24C256 module the memory address is the integer value, so we have defined an integer memory address. Now we have defined 1 byte variable, that is data to write, and we have set its value to 42. So this value will be written to the memory address 1. Now we are using the function write byte to EEPROM. We have defined this function here, write byte to EEPROM. We are not going into much detail about this function, just to keep it simple. And we have added one delay after the function. This is because every byte what we write to the EEPROM module takes about 5 milliseconds. So we have given 5 milliseconds delay after each write. Then after the data is written to the EEPROM, we are displaying the data into the serial monitor. Byte data written to EEPROM, the data to write. So writing is done. Now we have to read the value from the EEPROM. We are waiting 1 second. Then we are calling a function that is read byte from EEPROM. We have also defined this function here. This function reads 1 byte from the EEPROM. We are not going into much detail of this function also, just to keep it simple. Then after reading it from the EEPROM, we are storing into a byte that is data read. It's a variable. We are storing the value into this variable, and then in the serial monitor we are printing byte data read from the EEPROM, and it's printed in the serial monitor. And then we have given an infinite loop just to stop repeating this process. So we will upload the sketch into the Arduino. We already have one Arduino Nano on COM3. So we will upload the sketch now. Compiling, uploading, done uploading. So uploading is done. Now we will open the serial monitor. And the execution started. Byte data written to EEPROM 42. Byte data read from EEPROM 42. So in this simple application, we have seen how we can write one byte data to the EEPROM and then read that byte data from the EEPROM. If you have any confusion till now, please feel free to ask me in the comments. I will try to clarify all your confusions. Next, the application that we will see is we will try to write one integer instead of byte to the EEPROM and then read the value of the integer from the EEPROM. So for that, we are opening another program. So this program we have here, it will write one integer into the memory address and then read that back. It is almost the same program. We are adding one serial notification. First writing the data into EEPROM, then displaying it in the serial monitor, 1 second delay, reading it from the EEPROM and then displaying it into the serial monitor. Very simple program. And here are the functions, write integer to EEPROM and read integer from EEPROM. And we will also wait for the serial monitor to start. So while not serial, we will wait. Integer data, we have to keep it into the integer range. It's beyond the integer, it's going beyond the integer range. So we are writing something around 30,500. Now we will upload the sketch into the Arduino. This time we are writing to memory address 0. Uploading done. Let's start the serial monitor. See, integer data written into EEPROM 30,500 and integer data read from EEPROM 30,500. So you can see in this way we can write integer data into the EEPROM. It's also very simple. If you have any query or any question about this, please feel free to ask me in the comments. Now we will see another example where we can read and write float data into the external EEPROM. So we are opening another program. Here is the program to write float and read float from the EEPROM. It is also a similar program. We have one function to write float to EEPROM and one function to read float from EEPROM. I am not explaining much detail about the functions because it will make it complicated. I am keeping it simple, just making it as an example. So here we will keep the program waiting until we open the serial monitor. We will do the serial begin here in the setup. We are making few changes here just to display into the serial monitor. Okay, so first it will write into the EEPROM, then it will show what data is written into the EEPROM. Then after 1 second it will read from the EEPROM and it will show it in the serial monitor. We need to do a minor change here. because if we use this serial.println, the default value of the decimal place is 2, so we need to do the decimal place up to 5, as we have taken the float up to 5 decimal. So we are checking it up to 5 decimal points. Now we will upload the sketch. Uploading done, and let's start the serial monitor. Float data written into the EEPROM is 3.14159, this one, and float data read from EEPROM 3.14159. So in this way we can write float data and we can also read float data from the EEPROM. I am showing it into simple application so that you can understand it easily. If you have any confusion about this, please feel free to ask me in the comments. So we have seen 3 data types. Now one more data type, that is string. We will also see how to read and write string into the EEPROM. So here is the program that will write a string into the EEPROM and read the string back from the EEPROM. So it is also very similar. We have written 2 functions, write string to EEPROM and read string from EEPROM. These 2 functions will help us read and write. So it's the like same, device address 0x50, memory address 0, string data to write, hello EEPROM. We will write this string into the EEPROM and read it back. So wait until serial. After writing the data, it will print into the serial that data written to EEPROM is data to write, and then wait for 1 second. Then it will read the data. But in the case of a string data, first we have to determine the data length, because we do not know how much long the string is. So we have to determine the length of the string. So here we have determined the length of the string and kept it into a variable data length. Now a string variable data read, we will read the string from EEPROM. We have given device address, the I2C address, the memory address, and the data length. So how long the string will be read, and after getting it into this variable, we are printing it into the serial monitor, data read from EEPROM, that is data read, and then infinite loop to stop the looping here. Now we will upload the sketch into the Arduino. Uploading done. We are opening the serial monitor. See, data written to EEPROM, hello EEPROM, and data read from EEPROM is hello EEPROM. So in this way we can write string data into the EEPROM and read the string data from the EEPROM. So I have shown you 4 basic examples of different data types, how to read them and write them into the EEPROM. Now one more question comes, is how to clear the EEPROM. We do not know which memory location has which data. So before writing a new program, we have to clear the EEPROM. Now how to do that? So for that I am showing you another code, another sketch. You need not to worry, I will give you all the codes for download in the description section, so you can download the codes and test it for yourself. Now in this program, first we are starting with where begin, and here we have commented out 2 functions. One is clear entire EEPROM. After that the address is given, and clear EEPROM range. First the address is, the I2C address is given, then starting range, then ending range, and then in the void loop we have no code. Now we have 2 functions. One is clear EEPROM range. So if we want to clear a memory range from certain address to a certain address, we are using this function clear EEPROM range. And if we want to clear the entire EEPROM, we will use this function clear entire EEPROM. Then we will give the device address and it will clear the entire EEPROM. This sketch is just to show you how we can clear the EEPROM. I am not running this sketch, but I will give this code for you to download, so you can download and test it for yourself. So today up to this. Hope you liked the topic and I was able to make you understand everything very clearly. If you have any confusion, I have already said you can ask me in the comments. I'll try to clarify your confusions. If you like the video, please hit the like button and subscribe my channel. We will meet again in a new video. Till then, bye bye, take care. Thank you for watching.